High up in the Himalayas, deep within a limestone cave, water droplets freeze into a towering vertical pillar of ice. For centuries, this fragile natural structure has stood in total isolation. Historically, the atmospheric conditions allowed this ice formation to remain intact for a 57-day viewing window. Recently, that timeline shrank to a fraction of its former length. The ice vanished in just 5 days. Hundreds of thousands of people endure a grueling, high-altitude trek to see it. Now, many are arriving at the summit entirely exhausted, only to find a bare rock pedestal where the ice should be. The sudden disappearance has sparked intense debate. Many view the melting as a sign of divine wrath, a literal physical withdrawal by the gods. But an evaporation rate this extreme leaves a distinct thermal footprint. The collapse of the ice is a physical anomaly, and the explanation sits firmly in the realm of thermodynamics. To understand why the ice is disappearing, we have to look away from the heavens and examine the temperature data surrounding the mountain. The high-altitude Himalayan ecosystem operates as a massive, natural deep freeze. The surrounding geography historically regulated the air currents, keeping the valleys well below freezing. On this Himalayan thermal map, rising temperatures create a regional heat dome. Pressurized hot air overwhelms the traditional cool blue zones. Zooming into the Amarnath Valley, localized warming actively penetrates the region. The high-altitude air completely loses its sub-zero conditions. The mountain range is losing its ability to act as a protective barrier. The ambient air outside the cave is now hostile to ice regeneration. Beyond rising regional temperatures, human activity creates an immediate layer of heat. Thousands of internal combustion engines pump heavy exhaust directly into the mountain air. Modern aviation adds severe thermal disruption. Helicopters flying close to the peaks mechanically force warm, agitated air downward into valleys needing stable temperatures. Then comes the sheer physical mass of the crowd. Thousands of bodies and pack animals congest narrow pathways day and night, radiating continuous kinetic heat. The most aggressive damage happens right at the destination. Inside an enclosed space, every single human being radiates heat like a 98-degree furnace. This cross-section illustrates the microclimate greenhouse effect. Massive volumes of exhaled carbon dioxide pool against the ceiling, acting as an insulating blanket. Trapped body heat reflects directly back down. The rock cannot absorb the energy, pushing temperatures above freezing, rapidly degrading the ice. We observe this identical thermodynamic reaction outside the cave. Heavy foot traffic and exhaust fracture the surrounding foundational glaciers, cracking and pooling them into meltwater. We introduced extreme friction, exhaust, and massive body heat into a deeply fragile ecosystem. In the rush to secure a blessing, we accidentally engineered the exact conditions required to melt the shrine. The state of the ice reflects the physical impact of our own infrastructure and resource consumption. Treating a high-altitude geographical site like a high-volume tourist attraction breaks the physical limits of the mountain. The ecosystem lacks the capacity to absorb this scale of interference without fracturing. The vanishing of Baba Barfani is an early symptom of a much larger collapse. The surrounding glaciers currently experiencing this exact same thaw are the primary feedlines for the region's major rivers. When those glaciers shrink beyond the point of seasonal recovery, millions of people living downstream will face a permanent, severe water shortage. The ice is already giving way. The only remaining question is how much of the mountain has to disappear before we decide to listen.